Hi all, and welcome back to another episode of GCSE Science Simplified. What starts with a black powder and ends with bright blue crystals? Same copper, completely different form. Today's practical is about turning a messy reaction into a pure, solid product and understanding why every step matters. This is Chemistry Core Practical 3, Preparing copper sulfate. So let's look at the chemistry behind this. We're reacting sulfuric acid with copper oxide. Now, here's the key idea. A base reacts with an acid to form a salt and water only. Copper oxide is a metal oxide, so it acts as the base. Here's the reaction. Acid plus metal oxide makes a salt and water. In our case, sulfuric acid reacts with copper oxide to make copper sulfate and water. This is a neutralisation reaction. So, what do we actually do? We don't just mix and hope. Every step has a purpose. Step 1. We warm the acid. We need to gently heat the sulfuric acid to keep it safe, but more importantly, to increase the rate of reaction. If we warm it, particles move faster, there are more successful collisions, and that means a faster reaction. Step 2. Add the copper oxide. Bit by bit, stirring as we go, and at first it reacts and disappears. But eventually it stops disappearing and a black powder remains. That's your signal. The copper oxide is now in excess. But why do we do this? Because we need to make sure all the acid has reacted. If you didn't add excess, some white acid would remain, and that would mean our salt crystals at the end would be impure. Part 3. Now we've got excess copper oxide in our copper sulfate solution. So what do? We use filter paper, a filter funnel, and filtration. The solid copper oxide is the residue. The liquid or solution of copper sulfate is the filtrate. Now, this step is crucial. It ensures the solution now only contains our copper sulfate salt and water. Step 4. We need to turn this solution into crystals. Here's the transformation. You take the copper sulfate solution and gently heat it using a water bath. Why a water bath? Why not direct heating using a Bunsen? Because a water bath gives a controlled, gentle heating. The direct flame of a Bunsen would be too hot. Water would evaporate too quickly and the crystals don't form properly. So, now we're on to step 5, evaporation. You evaporate some of the water, not all of it, because we want to concentrate the solution. Which now leaves us to step 6. This bit's the easy bit, cooling and crystallization. You leave it, and this is where the magic happens. Blue copper sulfate crystals form. And here's the important point. Why not evaporate all the water when we're heating it? Because the crystals need time and space to grow properly. If you were to remove all the water, you just get a powder and not well-formed, nice, pretty crystals. So, what should we notice? The solution turns blue. That's the copper sulfate salt in there. The black copper oxide remains when it's in excess, and we need to clear that using filtration. Then, our crystals form as the solution cools and the water evaporates slowly. Right, safety and skills. We're working with sulfuric acid. This can be corrosive. Our hot liquids are potentially going to burn you. So, we need to heat it gently, handle carefully, wearing eye protection. And skills, we need to ensure that we're using a measuring cylinder to measure volumes, a glass stirring rod, beakers, and a water bath, naming our equipment as we go. Let's wrap this up. Metal oxides act as bases, and bases react with acids to neutralise, making a salt and water. We've got excess reactants to make sure that no acid remains in our solution, and we filter that out to get rid of it. Then we need to make sure we have gentle evaporation so that we get good big crystals. But we're not just making crystals. We're controlling a process to produce a pure salt. And we're proving it as we go. Next time, we'll move on to the next core practical and continue building your practical and exam skills. Thanks for listening to GCSE Science Simplified.